Namaste Gurukulians. Today we are going to learn our last topic, properties of integer of our first chapter, knowing our number. Properties of integers in case of additions, subtraction, multiplications and divisions. Let's start first property. First property of integer is closure. First property is closure. Closure property, if you take any two integers, and apply the operation, it may be positive, addition, subtraction, multiplication or divisions. After operation, we calculate the result and the result is any integers, then we say that the closure properties hold. Let's see with the example and in the only case. First, take any two integers. Let a and b be any two integers. A and b be any two integers. If we add them, a plus b, if we add them, after addition, if you get the same after addition, we get the integers, then we say that the closure property is hold in addition. Let's see with an example. Take a equal to 5, okay, and b equal to 7. It may be minus 7. Then we add 5 plus minus 7, but we get minus 2. 5 is an integer, minus 7 is also an integer. After addition, but we get minus 2, that is also an integer. So we then say that closure properties hold in addition. We take two integers, then we add them. If we get the integers, then we say that the closure properties hold. Next we go to the subtraction. Same things, we take two integers and then we have to subtract them. After subtraction, if we get integers, then we say that the closure properties hold. Let's consider the same. A and b are integers and we have to subtract them. So take a is same, a equal to 5 and b equal to minus 7. Subtract them, a equal to 5 and b equal to minus 7. Subtract it, what we get? 5 minus minus plus 7, that's equal to 12. That's equal to 12. 5 is an integer, minus 7 is also an integer. After subtraction, what we get? 12. 12 is also an integer. So we say that closure properties hold in subtraction. Next, in case of multiplication, take the two integers and multiply them. A and b are integers and we have to multiply the integers. A equal to I, same case. A equal to I and b equal to minus 7. Multiply it. 7 into 5, that is 35, and minus 1 appear one time, that is odd, so we mark it negative, that is minus 35. 5 is in integers, minus 7 is also in integers, their multiplication is minus 35, that is also an integers. After multiplication we get an integer, so we say that the closure property hold in multiplication. Next, division. Let's try. The closure property hold or doesn't hold in integers. A and b are two integers. A and b are two integers. And divide them, what we get? If we get integers, then we say that the closure properties hold in division. If we don't get any integers after divisions, then we say that doesn't hold in divisions. Take the same example. A equal to 5, b equal to minus 7. A equal to 5, b equal to minus 7. That's if we calculate what we get. 5 divided by minus 7. That's also not an integer. So we say that closure property does not hold in divisions. I remind it. Closure property, we take any two integers, then we have to operate addition, subtraction or multiplication and divisions. If we get the integer, then we say that the closure properties hold. First a and b are two integers, then divide, we have to add them, we get an integers, we say that the closure properties hold. If we subtract them, we get an integers, then we say that the closure property hold in subtraction. And if we take two integers a and b, multiply both, and if we get integers, then we say that closure properties hold. But remind, closure property doesn't hold in division. A and B are two integers, we have to divide them, and what we get after divisions? 5 plus 7, which is not an integers. So we say that closure property doesn't hold in division. Next property is commutative. Next property is commutative. In commutative property, we have to take two integers. Then apply the operation: addition, subtraction, multiplication, or division. Maybe anyone. If we get the same result after changing their order, then we say that the closure properties hold. Let's see in the case of addition. A and B with two integers. We have to add them. A plus B. If it's equal to B plus A, that is, change the order of integers. Here A is first, here B is first. We have to change the order of integers. If this hold, then we say that closure property, commutative properties hold in addition. Let's try with this same example. A equal to 5, B equal to minus 7. This is our left hand side. What we get? 5 plus minus 7, that is equal to minus 2. In right hand side, B equal to minus 7 plus A equal to 5. What do we get? Minus 2. Left hand side equal to right hand side. So we say that closure commutative properties hold in addition. Commutative properties hold in addition. We take two integers, we have to add and change their order. Here A plus B and here is B plus. If both are same, then we say that closure properties hold. Commutative properties hold. Next, subtraction. Subtraction is same. We have to change the just operation. Here A minus B, if equal to B minus A, we have to change the order of the integers. A minus B equal to B minus A. If this is hold, then we say that the commutative properties hold in subtraction. Let's take the same integers. A equal to 5, left hand side. A equal to 5 and B equal to minus 7. That is equal to 5 plus 7, that is equal to 12. Next, take right hand side. Right hand side is B minus A. B equal to minus 7 minus A equal to 5. A equal to 5. Add them, that's equal to minus 12. See the difference. Left hand side we get 12, right hand side we get minus 12. These are not same or not equal. Then we say that commutative property doesn't hold in subtraction. That's not hold. If they are not equal, we can mark a line like this. Then we will say that A minus B not equal to. Read it. Not equal to. This is the symbol of equal. If you mark cross or cut it, then we say that not equal to B minus A. That is A minus B not equal to B minus A. Then we say that doesn't hold commutative property in subtraction. Next is in multiplication. Multiplication, we take two integers A and B and multiply up and change their order. A minus B multiply B minus A. That's equal to, if A minus B equal to B minus A, then we say that the commutative properties hold in multiplication. Let's try. Take the same example. A equal to 5, B equal to minus 7. That's your left hand side. Left hand side. Multiply it. 5 into 7, that is equal to minus 30. Next take right hand side. Right hand side. That is b minus a. Change the order. B equal to minus 7 and a equal to 5. After multiplication, what we get? After multiplication, what we get? 7 into 5, that is equal to minus 35. Here both are same. A minus b equal to b minus a. That is commutative property hold in multiplication. And the next, in case of division, let's try commutative property hold or doesn't. Take a divided b and this is the order. B divided a. If this is hold, then we say that commutative property hold in division. Let's take this same. A equal to 5 and divided by b equal to minus 7. What we get? Minus 5 by 7. That is a equal to 5, b equal to minus 7, divided 5 by 7, that is equal to 5 by 7. Take right hand side. b equal to minus 7, divided by a equal to 5, that's equal to minus 7 by 5. See the difference. Is they are same or not? Here is the minus 5 by 7 and there is minus 7 by 5. Both are not equal, so we say that a divided b not equal to b divided a. And that's why we say that commutative property does not hold in division. See it again, commutative property. If we take two integers and change their order and apply the operation, if we get the same result, then we say that commutative properties hold. Take two integers a and b, we have to add and change the order. A plus, here is a plus b, then b plus a. If both are equal, then we say that the property hold. If they are not equal, then doesn't hold. And you clearly see that commutative property doesn't hold in subtractions and divisions. Now we discuss the third property of integers, that is associative. Associative property of integers. In associative property, we take three integers and we have to add two first and then the third. If the result is same in the let's take, then we say that it's closure. Associative properties hold. Let's try. Third property, associative. Associative. We take three integers a, b, and c. We take three integers a, b, and c. If a plus b plus c equal to a plus b plus c, then we say that associative properties hold in addition. Here is the difference is that three element and we make a group of a plus b and here is make a group of b plus c. We change the order of group. First we add this with c. Here we first add b plus c with a. If this is hold, then we say that the associative properties hold in addition. Same in subtraction, just change the sign. Here plus we can change with negative, minus, and multiplication we change it with negative multiplication, and same with divisions. Let's see. Take a equal to 2, b equal to 3, and c equal to minus 7. Put left hand side. Left hand side a plus b plus c. Here a equal to 2, b equal to 3, and c equal to minus 7. Minus 7. Add that. 2 plus 3 that is 5 plus minus 7 that equal to minus 2. Take right hand side. Right hand side. Right hand side is a plus b plus c. A is put the a value a equal to 2 plus here is the group b plus c. b equal to 3 and C equal to minus 7. Add them. 2 plus 3 minus 7, that is equal to minus 4. That is 2 minus 4, that is equal to minus 2. Left hand side and right hand side. Here both are equal. Then we say that associative properties hold in addition. Associative properties hold in addition. We have to take 3 integers, any 3, A, B, C, and change the order of group. First we make the group of A plus B, and here we make the group of B plus C. If left hand side and right hand side equal, then we say that associative properties hold. Same thing is subtraction, but just change its sign. A minus B minus C. If equal to A minus B minus C, then we say that associative properties hold in subtraction. Let's try with the same example. Left hand side put A equal to 2 minus B equal to 3 and minus C equal to minus 7. Calculate it. 2 minus 3, that is equal to minus 1, minus plus 7, that is equal to 6. Now take right hand side. Right hand side put A equal to 1, A equal to 2 minus B equal to 3, B equal to 3 minus C equal to 7. Sheet A equal to 2 minus B equal to 3 minus C equal to minus 7. Solve it. That is equal to 2 minus 3 minus plus 7. That is equal to 2 minus 10. That is equal to 8. 3 plus 7, that is equal to 10. 2 minus 10 equal to 8. See the difference. Left hand side is 6, but right hand side is 8. They are not equal. So we say that associative property does not hold in subtraction. Associative property does not hold in subtraction. Let's try with multiplication. Take any 3 integers and make the group of A cross B cross or multiply with C. If this is equal to A cross B multiply with C, you have to change just their group. Change their group. What we get? Right with the same example. Left hand side. Put A equal to 2, B equal to 3 and C equal to minus 7. Solve it. First we solve this group. 2 into 3, 6 into minus 7, that is equal to minus 42. And right hand side is A equal to 2 multiply B equal to 3 and C equal to minus 7. First we solve this one, that is our group, right? 3 into minus 7, that is equal to 21 and 21 into 2, 42 and minus 6 here. Left hand side is equal to right hand side. So we then say that associative properties hold in multiplication, but in case of division, associative property doesn't hold. We see it. Take A divided by B, divide C. If equal to A divide B divide C, then we say that associative associative properties or in division. Take the same example. Put A equal to 2. Left hand side, A equal to 2. Divide by B equal to 3. Next, divide by C. C equal to minus 7. First we solve this one. That is our proof. 2 divided by 3, we can say that 2 by 3. Divide by minus 7. Or we can write it 2 by 3 divided by minus 7 divided by 1. If we see the sign of division, we can interchange it, reverse it, change the division sign into multiplication and reverse the integer, that is minus 1 by 7, and solve it. What we get? 2 by 21 minus 2 by 21. Now right hand side. Take A equal to 2 divided by B equal to 3 divided by C equal to minus 7. And now this is our group. We solve it first. That is 2 divided by 3 divided by 7. That is equal to 3 by minus 7. Now divide it. 2 divided by 3 by 7. 2, change the sign of division into multiplication and reverse or invert the integer. Minus 7 by 3. Multiply it. 2 into 7, that is equal to minus 14 divided by 3. I repeat it. Right hand side, put A equal to 2, B equal to 3 and C equal to minus 7. This is our group. First we divide it. 3 divided by minus 7, that is equal to 3 by minus 7. And our equation is 2 divided by 3 by 7. Now change the division sign into multiplication and reverse the integers. That is equal to 3 by minus 7 converted to minus 7 by 3. 2 into minus 7, that is 14 divided by 3. Here we find left hand side 2 by 21 minus, and here is minus 14 by 3. Both are not same. Or we can say that A divided by B divided by C does not equal to A divided by B divided by C. So we say that does not hold in division. This is our third property, associative. Now we start with our fourth property. That's 0. Addition. If we add 0 to an integer, subtract 0 from an integer, multiply division 0 with an integer, and last divide 0 with an integer. Let's start. Property of 0. Or properties of 0. If let A be any integer, if we add 0 to them, what we get? Same integer. Let's give you an example. Take an integer, that is minus 7. If we add 0, what we get? Minus 7. If we add 0, it doesn't change. Next, if we subtract 0 from an integer, subtract 0 from an integer, what we get? Same integer. 0 doesn't affect. See the example. Minus 7 minus 0. What we get? Minus 7. 0 doesn't affect. But in case of multiplication, if we multiply any integer with 0, what we get? 0. It may be positive integer, that is minus 7 multiplied with 0, what we get? 0. And the last one, division. If we divide 0 with any integer, we get 0. If we divide 0 with any integer a, we get 0. That is 0 divided by 7, but we get 0. If we divide 0 with an integer -9, that we get 0. It doesn't affect. But if we divide any integer with 0, what do we get? This point should be noted. If we divide any integer with 0, what do we get? This is not defined. This is not defined. This point should be noted. This is not defined. We learn about this in higher classes, but now you have to learn we can't divide any number with 0. Next property. Property of 1. Property of 1. Or simply 1. If we add 1 with an integer, what do we get? Next one. Next integer. That is, if we add 1 with 6, but we get 7. If we add 1 with 7, but we get 8. If we add with 1, if we add 1 with an integer, we get the next integer. If we subtract 1 from an integer, what we get? The previous integer. That is, we get 6 minus 1, but we get 5. If we subtract 1 from 16, but we get 15, the last one. If we subtract from, it may take negative, but we get the last integer. But in case of multiplication, we have to multiply an integer with 1, but we get the same integer. But we get same integer. And see the example, 5 into 1, that is equal to 5. Minus 7 into 1, that is equal to minus 7. If we divide any integer with 1, but we get the same integer. That is, if you divide 7 with 1, we get the 7. And if we divide minus 7 with 1, we get the minus 7. And here is a 0. If we add 0, but we get the same result. If you multiply 1 with an integer, we get the same integer. 0 also called is also called additive identity. 0 is also called additive identity. And 1 also known as multiplicative identity. Multiplicative identity. 0 is known as additive identity and 1 is called multiplicative. Next, properties. Next properties, two properties left: inverse and distributive. First one, inverse. Inverse exists only in two: multiplication and addition. multiplication and inverse. Multiplication and division inverse. If a is an integer, what we get, or what should the integer divide? So add with the integer to get additive identity, that is 0. Or simply we can say that minus 8. Let's see with an example. That is 5. What we have to add to get identity? That is additive identity. That is equal to 0. That we can say that minus 5. 5 is an integer, then minus 5. That is equal to 0. A is an integer, minus a is an additive inverse of integers. And same in multiplication, subtraction inverse does not exist, and same in multiplication. Multiplicative inverse. Take an integer a, multiply with an integer, so we get multiplicative identity, that is 1. So we have to multiply 1 by a. That is over multiplicative inverse. See it with an example 5. Multiply with an integer number, so get 1. We can multiply 1 by 5. That is equal to 5 into 1 by 5 equal to 1. Or we can simply say that multiplicative inverse of an integer is 1 by a. And the last property. Last property is distributive, which only exists in multiplication. Distributive property. Distributive property of multiplication. That is, we have 3 integers a, b and c. Then if we multiply a into b plus c, we can directly say that a into b plus b into c. A into b multiply, so in addition with b plus c. Let's take an example. Take a equal to 2, b equal to 3 and c equal to 4. Take left hand side. Put it a equal to 2 plus b equal to 3 and c equal to 4. We have to add this 2. Here is the multiplication. 2 plus 3 plus 4, that is 3 plus 4 is equal to 7. 2 into 7, that is 14. And the right hand side, 14. A, put the value of a equal to 2, b equal to 3 plus, here is the difference, put a. So for that, write a into b plus c, that is equal to a into b plus a into c, and a equal to 2 multiplied with c equal to 4. Add it, 2 into 3 6 plus 2 into 4 8, that is equal to 14. Left hand side is equal to right hand side. And if we find here difference or sign of negation, that is equal to b minus c, then it is equal to a multiplied b minus a multiplied with c. That's it. Now, how the question is asked about on the basis of these properties. Let's see few examples. First question, multiply minus 11 23 plus minus 10 with the help of distributive property. with the help of distributive property. Let's try. Sheet, this will look like A multiply B plus C. A into B plus C. That will be open A into B plus A into C. Compare this. A equal to minus 11, B equal to 30 and C equal to minus 10. Put here A equal to minus 11. Multiply it with B equal to 23 plus A equal to minus 11. Multiply it with C equal to minus 10. Solve it. Minus 11 in 23. That is equal to 253. 253. Minus sign is one type, so we put here minus, that is odd. But here 11 into 10, that is 110. Minus minus plus, or we simply add them. 143 is our answer. And the last question from additive property. Add minus 13 plus 34 using commutative property. Commutative property. What's the commutative property? Commutative property hold in addition, that is equal to A plus B equal to B plus A. Change the order. Minus 13 plus 34 equal to 34 minus 13. That is equal to 1, 2, 21. That is the last question. Now do your homework, assignment and PDF that we provide. Complete them and ask their queries in your respective group. Thank you.